Hey you guys, this is the Chapter 4 review. Our tests tomorrow are on sections 5 through section 8 in Chapter 4. So let's first work out these first 6 problems. In these 6 first problems, the directions are to simplify each expression. So looking at number 1, right now the first thing I see is that there is a square root with a negative inside. And we know that we don't want to deal with negative square roots. So we're going to take out the imaginary number and turn that into a positive 9. So we have 4 plus 5i square roots, and now that 9's positive. So all I did in that first step was I recognized that the 9 was inside of the radical and it was negative. So in order to turn it positive, I brought the imaginary number out front of the radical. And already in front of the radical was a 5, so they multiplied together to get 5i. At this point, I still have a radical, and I want to simplify that as much as possible. 9 happens to be a perfect square, so the square root of 9 is 3, and I no longer need that square root sign. So I have 4 plus 5i, and in place of the square root of 9, I'm going to put a 3. Now that 5i and that square root of 9, they were multiplying. So the 5i and the 3, they're multiplying. So I still have the 4 in front, but now 5i times 3 is 15i. So now I'm left with 4 plus 15i. You're going to be tempted to add those together, but you should realize that one of them has an i and the other one doesn't. So we cannot combine those. So we're left with our final answer. So I'm going to just box that in, 4 plus 15i. And go ahead and get used to boxing it in now on your study guide because our test is going to look just like this. So you'll want to make sure that you box in your final answer. Number 2. Number 2, we also have a square root with a negative number inside. And so we'll want to take out that i right away to turn that positive. And once we do turn that positive, that number inside, though, is 25. So we have a square root of a positive 25 now inside. 25 is another perfect square, and you know the square root of 25 is 5, and so I'm going to take that out also with the I. So now I have 5i, and then the parentheses 3 minus I. At this point, I have parentheses. Inside of those parentheses are terms that I cannot combine. So to undo the parentheses, I'm just going to distribute. So 5i times 3, I get 15i. And then 5i times negative I get negative 5i squared. Remember, anytime you see an I squared, you want to cross that out immediately and change the sign. So to simplify this, I have 15i. And since I crossed out the I squared, I'm going to change my sign to a positive 5. And that's all I have to do. 15i and then positive 5, they are not like terms, so I can't combine them. But you know me, I like to leave things written in the correct form, and that means real numbers are first, followed by imaginary numbers. So 5 plus 15i would be my final answer, and this is what I would circle or box up. Looking at number 3, we see we have 2 sets of parentheses. So first thing that you would think to do is to distribute, but if you take your time and you really look at the problem, you'll see that in between the parentheses is an operation symbol, and that symbol is a subtraction sign. So we're really not multiplying, we're really subtracting. So the first step is to remove these parentheses. So 8 plus 2i in our first parentheses, they're going to stay exactly the same because nothing's changing them. But the second parentheses, we have that minus sign in front. So you'll have to distribute that minus sign or distribute the negative. And what that really does is just changes your signs inside of those parentheses. So the 3 was positive and now it becomes negative. And the 4i was negative, so that becomes positive 4i. Now we're just going to combine like terms. So we're looking to see here which terms are similar. We have an 8 minus 3. 8 minus 3 is 5. We also have a positive 2i and a positive 4i. So we get a positive 6i. 5 plus 6i, we don't have like terms, so that's our final answer. All right, moving on to number 4. Number 4 is simply just a radical with a negative number inside. So immediately we're going to take out the imaginary number. So this is going to turn into I square root of 28. Now that 28, it's not a perfect square, so we're going to have to break it down using the border method. So I'm going to write it to the side, 28 on one side, and then I'm going to start with the smallest prime number, which is 2. So 2 goes into 28 14 times. 2, again, because it goes into 14 evenly, and it goes in 7 times. 2, however, doesn't go in evenly into 7. So I go to my next prime number, which is 3. 3 doesn't go into 7 evenly, so my next prime number is 5. That one doesn't work, but my next prime number is 7. That goes in evenly, and it goes in 1 time. Once you get to 1, remember, you're done. So now we're looking for pairs. We don't care about this right side, we care about the left side, and I have a pair of 2's. The 7, though, does not have a pair. So outside comes the 2. Already outside is the I. And the only number that doesn't have a pair is the 7. So that stays inside of the radical. So my final answer here is 2i square roots of 7. Moving on to number 5, we have another problem with 2 sets of parentheses. But in this case, there is no operation symbol in between the parentheses. So we are simply just going to multiply. And it might not be clear in this video, but on your piece of paper, on your study guide, it says 3 plus 4i and 5 minus 2i. So when we distribute, I'm going to say 3 times 5, I get 15. Then 3 times negative 2i. Make sure you distribute the 3 to both of those terms. And we get minus 6i. Then we have 4i times 5, so positive 20i. And then 4i times negative 2i, so we get negative 8, and then I squared. All right. So now we're looking to simplify this. Combine any like terms, simplify any I squares. So right away I see an I squared, so I'm going to cancel that out, and I'm going to change the minus to a plus. Also, I see a negative 6i and a positive 20i. So those are like terms that I could combine. So I have 15, and then I have a positive 8. That gives me a positive 23. And then negative 6i plus 20i gives me a positive 14i. And remember, you only get I squared when you're saying I times I. But when you're just adding, then it stays I because you just keep your like term. So there's my final answer. Looking at number 6, we're dividing here. And it's important to remember that when you're dividing, you're not allowed to have an imaginary number in the denominator. So to undo that, or to get rid of that imaginary number, we're going to multiply both the numerator and the denominator by the conjugate of the denominator, by the opposite. So I'm going to multiply both numerator and denominator by negative 3i, which is the opposite of positive 3i. I also see that in my numerator to begin with, I have a binomial, so I'm going to put parentheses around that to help me to remember to distribute. So when I do distribute, I get 2 times negative 3i, so I get negative 6i, and then negative 4i times negative 3i. 2 negatives make it positive, 4 times 3 is 12, and then I times I is I squared. Before I move on to the denominator, I'm going to simplify this a little bit more. Remember, whenever you see an I squared, you want to cancel out that I squared and change your sign to a minus. or not always to a minus. You just want to change the sign. So really in the numerator, I'm going to write that negative 12 first, and then I have a minus 6i. Now we can go ahead and multiply the denominator. So we have 3i times negative 3i, and we get a negative 9i squared. Again, we have an I squared, so we're going to cancel that immediately and change the sign. So it was minus, so now it's positive. And in the denominator, I now have a positive 9. Now we no longer have an imaginary number in the denominator, so that's good. But if we can simplify these three numbers, then we want to simplify it. And remember, all three have to be divisible by the same number in order to simplify it. I have 12, 6, and 9, and all of them are divisible by a 3. So I'm going to divide all of them by 3. So negative 12 divided by 3, I get negative 4. Negative 6i divided by 3, I get negative 2i. And then 9 divided by 3, I get 3. So here's my final answer. Negative 4 minus 2i, all of it divided by 3. So I'm going to box that in. Now let's look at problems 7 through 10. The directions here say solve each quadratic equation. In order to solve for each 7 through 10, we first need to make sure that they're in standard form. Standard form is ax squared plus bx plus c. It needs to be equal to 0. So if it's not equal to 0, then whatever is on the right side, we need to move to the left side. You want your standard form from the highest exponent to the lowest, and then set equal to 0. So in number 7, we're good to go. In order to solve, we could solve two different ways. You could solve by factoring, or you could solve using the quadratic formula. It's really up to you. Now, not all of these problems could we solve by factoring. Some of them you could only solve by using the quadratic formula. So since that's the case, that's what I'm going to use. And since I'm going to use the quadratic formula, I'm going to write it over here in the corner. I'm going to say x is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, and this is all divided by 2 times a. And I suggest you write that down somewhere on your paper right away when you get the test. As soon as you get the test, write down the quadratic formula. All right, so back to number 7. First thing after checking that it's in standard form is to identify your a, b, and c. So a is equal to 1, b is equal to negative 10, and c is equal to positive 21. All right, so I'm just going to go ahead and plug that in. Sorry, it's so messy. I'll write it a little bit more clearly. B is equal to negative 10, and c is equal to positive 21. Okay, so x equals opposite of b. So b was negative 10, so we have positive 10, plus or minus square root b squared, so negative 10 squared, minus 4 times a, which is 1, times c, which is 21. And this is all divisible by 2 times a, which is 1. So simplifying inside the radical first, I get 10 plus or minus square root 100 minus 4 times 1 is 4, and 4 times 21 is 84. And this is divisible by 2 times 1, which is 2. So x is equal to 10 plus or minus square root of the square root of 100 minus 84. 100 minus 84 is 16, all over 2. So x is equal to 10 plus or minus square root of 16 is 4 divided by 2. At this point, we want to rewrite our answer as two separate answers. So I'm kind of running out of room here. I'm going to try to section off room for me to write without going into the next area and having to erase it. Okay, so one of my answers, I'll go a different color. One of my answers is going to be x is equal to 10 plus 4 over 2. And the other answer is x is equal to 10 minus 4 over 2. I'm going to have to erase this in a second because I'm just running out of room. But 10 plus 4 for the first one is 14, and 14, so let's write this, is 14, and 14 divided by 2 is 7. And then in the second answer, 10 minus 4 is 6, and 6 divided by 2 is 3. So our two answers here are 7 and 3. I'm putting those in braces. So I'm going to come back over here. I'm going to erase this in blue so I can write my answer out. So my answer, one of my answers is 7, and the other answer is 3. Perfect. I can't seem to erase this other one. Okay, I can't manage to erase the 7 and 3 over here, so we're just going to cross it out so you don't get confused later, and I don't get confused. All right, so let's look at number 8. Number 8, we need to do the same thing, but before we can begin, we need to move that 9x to the left side because we want it equal to 0. So it's positive 9x, so in order to move it, we're going to subtract it to the other side. And when we subtract the 9x to the other side, well, there's no like terms for us to combine it with. And the x term belongs in the middle, so when I rewrite this, it's simply going to be positive 2x squared minus 9x plus 10, and it's now equal to 0. All right, so we set up the quadratic formula. We need to determine our a, b, and c. So a is equal to 2, b is equal to negative 9, and c is equal to 10. Going ahead and plugging this in, we get x is equal to opposite of b, so 9, plus or minus the square root of b squared, so negative 9 squared, minus 4 times, here I go again, going into the other box, 4 times a, which is 2, times c, which is 10. Extend that. And it's all divisible by 2 times a, so 2 times 2. All right, so simplifying, I get 9 plus or minus, and if you simplify all of it that's inside, negative 9 squared is 81, 4 times 2 is 8, 8 times 10 is 80, so 81 minus 80 is 1. So you're left with 1 in there, and 2 times 2 is 4. All right, well, we know the square root of 1 is 1, so we have x is equal to 9. Oops. Let's see if I can erase that. Put a 4 back here. So 9 plus or minus 1, and it's all divisible by 4. Oh, this is horrible. It's running out of room. Try it again. 9 plus or minus 1, all divisible by 4. Okay, that looks a little bit better. So now we just split that up to get our two answers. So we're going to say 9 plus 1, and we get 10, and 10 divided by 4, so it's 10 fourths. And when you reduce that, that becomes 5 halves, or you just get 2.5. So one of our answers, I'll bring it up a little bit, we'll write it right below here. One of our answers is 2.5. Our other answer is 9 minus 1, which is 8, and 8 divided by 4 is 2. So So these are the two answers we get once we split it apart and solve. So here's our answers for number 8. All right, let's look at number 9. And I'm going to erase some of this work from number 8 so we can look at number 9, or we can have room for it. Oh man, I can't erase that either. Okay, continuing on then. So in number 9, this is already in standard form and it's set equal to 0. So I just need to identify my A, B, and C. We'll use a different color at least so we're not getting it mixed up. A is equal to 9. B is equal to -6. And C is equal to -11. Alright, so plugging this in, we get X is equal to opposite of B, so +6, plus or minus the square root of, and now it's B squared. So B squared is -6 squared, which is 36. Minus 4 times A. 4 times A is 36 times C. So 36 times 11. Well, 36 times 10 is 360. So then 360 plus 36 is 396. And since it was a negative, this is going to turn into a positive 396. And this is all divided by 2 times A, so 2 times 9, which is 18. When I add together what's inside of my radical, I get X is equal to 6 plus or minus the square root of, let's see, 6 plus 6, 2, carry the 1, 10, 3, carry the 1, 4. So 432, and this is all divisible by 18. Alright. Alright, so I cleared up a little bit of room. Square root of 432 is not a perfect square, so using the border method, we're going to break it down. Remember, we start with our smallest prime number. So 2 goes into 432, see, 216 times. Then 2 goes into 216, 108 times. 2 goes into 108, 54 times. 2 goes into 54, 27 times. And 2 doesn't go into 27. So then we move to 3. 3 goes into 27 9 times. 3 goes into 9 3 times, and 3 goes into 3 1 time. We got to 1, so we're done, and now we're going to circle up some pairs. So we have a pair of 2s, so a 2 gets to leave the house. We have another pair of 2s, so another 2 gets to leave the house. We have a pair of 3s, so a 3 gets to leave the house, and then we have a 3 that's solo, so that 3 has to stay home. So 2 times 2 is 4, and 4 times 3 is 12, so it reduces to 12 square roots of 3. So what I have down here then is X is equal to 6 plus or minus 12 square roots of 3, all divided by 18. And that looks like you might be done, except we need to look at these 3 numbers. We have 6, 12, and 18. We can't touch the 3 because it's inside of the house. And remember, if you're inside the house, you're safe. But 6, 12, and 18, they're all out in the neighborhood and anything could happen to them. So since these 3 numbers have a greatest common factor, we can divide them by that GCF. We can reduce these 3 numbers. So 6, 12, and 18, they're all multiples of 6. So I'm going to divide each of those by 6. And my final answer then is going to be, let's see, where am I going to put this? I guess I'll put this down here. When I divide by 6, I get 1 plus 2 square roots of 3 divided by 3. Because I'm dividing the 6 by 6, so I get 1, 12 by 6, so I get 2, and 18 by 6, so I get 3. So this is one of my answers. And the other answer is the same thing, just instead of the plus sign, it's going to be the minus sign. All right, so we're done with number 9. Here's my answers for them. Now box those in so we can tell. All right, and then moving on to number 10. We're going to have to find some room for this. Okay, so as you can see, I cleared up some room for number 10. So it's set equal to 0. It's in standard form. So I'm going to label my A, B, and C. So my A here is equal to 2. My B is equal to 8. And my C is equal to 9. So I have X is equal to the opposite of B, so negative 8, plus or minus the square root of B squared, so 8 squared, minus 4 times A times C. And this is all divided by 2 times A, which is 2. So simplifying this up, I get X is equal to negative 8 plus or minus the square root of 8 squared is 64, minus 4 times 2 is 8, and 8 times 9 is 72. And this is all divisible by 4. Now I get X is equal to negative 8 plus or minus the square root of 64 minus 72, and I get negative 8, all divisible by 4. Now I have a negative inside of the radical, so to make that positive, I just need to take out the imaginary number, the I. So my answer becomes, and I'm already out of room, I'm going to start it over here. So my answer becomes X is equal to negative 8 plus or minus I square roots of 8 over 4. So now that 8's positive inside of the radical, and I need to break it down. It's not a perfect square, but it can be simplified. So using my border method, starting with 2, 2 goes into 8 4 times, 2 goes into 4 2 times, 2 goes into 2 1 time. So 1 and you're done. We have a pair of 2's, so 2 comes out, and then we have a 2 that doesn't have anyone, so he stays home. So this simplifies to X is equal to negative 8 plus or minus 2I square roots of 2 over 4. And as you can see, the 8, the 2, and the 4, they're all outside of the house. So we can reduce those three numbers. They're all divisible by 2. So one of our answers is going to be dividing negative 8 by 2. It's negative 2 plus 2 divided by 2 is 1. So 1I square roots of 2. Remember, you can't touch that 2 inside of the radical. He's safe in the house. And 4 divided by 2 is 2. And the other answer is exactly the same, it's just with the minus sign. So negative 2 minus I square roots of 2, all of it over 2. Perfect. So here's our answer here. All right. So now we're going to move on. And we're going to check out 11, 12, and 13. And these are the last ones I'm going to do with you. The rest of your study guide is to look up the definitions and to make sure you understand those vocabulary words on the back. So I have confidence that you guys can do that all by yourself. Alright, so for numbers 11 through 13, it says find the discriminant and determine the number of real solutions for each equation. Remember, for the discriminant, we use part of the quadratic formula. The part that we use is b squared minus 4 times a times c. And that's all we use there. For these problems, you're going to want to refer back to the table that we made in our notes. That might help you along, and you'll definitely want to memorize that table for the test tomorrow. So, in order to use the b squared, in order to use the b squared minus 4ac, the quadratic equation needs to be set equal to 0. Right below 11, 12, and 13, it says sketch a possible graph representing the number of real solutions of each quadratic equation. So we want to make sure we know what the graph looks like for each one also. So for number 11, a is equal to 1, b is equal to 6, and c is equal to 9. So when we plug that in, we get 6 squared minus 4 times 1 times 9. So we get 36 minus 4 times 1 is 4, and 4 times 9 is 36. 36 minus 36 is 0. Remember, when you get your discriminant, and this is our discriminant, we want to see, is it greater than 0? Is it equal to 0? Or is it less than 0? In our case, our discriminant is 0. I'm going to want to go ahead and box that in because that's one of our answers. It says determine the number of real solutions. If it's equal to 0, then I only have one real solution. And remember, that's my double root. So the graph for this is going to look like this. Here's my x and y, and my graph is just going to touch the x-axis. So a sketch of it would just go down, touch it, and turn around. Don't forget to put arrows on your graph. Now you could sketch it like that. You could sketch it to the right or to the left, but it wouldn't be upside down because our x squared is positive, so we know that it's going up. All right, let's look at number 12. Number 12 is already set equal to 0. So our A is 3, our B is 4, and our C is 5. So plugging that in, we're going to say 4 squared for B squared minus 4 times A times C. So 4 squared is 16. 4 times 3 is 12, and 12 times 5 is 60. So 16 minus 60. So we get a negative 44. 16 minus 60 is negative 44. And again, we're saying this is our discriminant. And we're going to look at our discriminant and determine, is that greater than 0, equal to 0, or less than 0? In this case, it's less than 0. So we have 0 real solutions. What kind of solutions do we have? If we have 0 real, then we have 2 imaginary. But you want to make sure that you read the question on the test. This one says determine the number of real solutions. So we have 0 real solutions here because our 2 solutions are imaginary. If we wanted to sketch this, since we have 2 imaginary solutions, that means we don't have any x-intercepts. So my graph would not be touching the x-axis. It would be something like this. And again, we have arrows on the ends. So that would be a sketch for number 12. Our last problem. Looking at number 13. This also is in standard form. It's equal to 0. So your A is equal to negative 2. Your B is equal to negative 5. And your C is equal to 1. So using B squared minus 4AC, I get negative 5 squared minus 4 times negative 2 times 1. So I get 25 plus 8, and 25 plus 8 is 33. This number is greater than 0. 33 is my discriminant. And since it's greater than 0, I have 2 real solutions. Now the graph for this, with 2 real solutions, and in this case I have my x squared term, it's negative 2x squared, so I know my graph's opening down, and I know I have 2 real solutions, so I have to cross the x-intercept twice. So my graph's going to look something like this. So that would be a sketch of the graph. And that's it, you guys. That's number 13. You guys have your test tomorrow. So please, please, please study. Finish the rest of the study guide on your own. The whole second half of your test is vocabulary. So make sure you understand those vocabulary words. All right. Good luck studying. I'll see you tomorrow.